Hello everyone, my name is Marshall Edens. This is my final project proposal for Geography 481. The purpose of my project is in relation to my work. I'm a school teacher at a high school, a science teacher. Every year we take 150 or so students on what we call our outdoor school experience. This experience has them navigating around the nature preserve and completing tasks that we have for them, which relate to their lessons in ecology mostly. For about 20 years, we've been taking students on this experience, and since that time, they have been navigating using a simple hand-drawn map, which has sufficed and is totally workable, but my project seeks to update those maps. Part of what prompted this update or need for an update to go digital was during the pandemic. We attempted to give students a virtual version of that experience, and we noticed that if we had a map on which to base the activity or the virtual version, it would have been very nice. It would have kept kids sort of in the space, so to speak. And every year, even non-COVID years, we have students who are unable to attend for various reasons, medical conditions or what have you, and a virtual version would be a nice addition to our system, to our activity. The project area is Steinman Run Nature Preserve Trail in southern Lancaster County. It's about 7 miles south of the city center of Lancaster. The nature preserve is 309 acres in size, and its specific location is 39.9 degrees north by 76.3 degrees west. My project will use LiDAR-based data to update these maps and produce the new digital maps. My maps will show the boundary of the nature preserve. It will outline trails, streams, and other points of interest. And it will provide contours so students can keep track of elevation. The data was sourced from the PASDA clearinghouse. There were 6 files listed here at the bottom. They're 5,000 by 5,000 foot tiles. They contain pre-classified data, but the nature preserve is entirely encompassed in these 6 tiles, including our bus drop-off site, which is one of the points of interest. Data collection was done in the spring and fall of 2019 by a company called Quantum Spatial Incorporated. It doesn't say outright that this was an aerial platform, but I'm making an assumption that this was. The sensors used are the Rigel VQ1560i, the Leica ALS80, and Optec Galaxy T1000. I'm not entirely sure which of these sensors were used to collect the data that I found. It does not state specifically. The metadata files for all 6 of my LAS files are identical to one another, and so this data collection encompasses all of Lancaster County, including some other counties in Pennsylvania. So I'm not entirely sure if all 3 sensors were used in my area or if this was statewide. They used a variety of these sensors. It's not clear. But it is clear that the coordinate systems used was NAD83 State Plane PA South FIPS, feet US, and the vertical datum is NAVD88 Geoid 12B, also in feet. Mentioned that the data is classified already. in LAS 1.4 format. Some specs for the data. It lists a nominal point spacing of 0.71 meters, point density of 2 points per meter squared, and has a 0.134 meters NVA at 95% confidence interval. And it mentions that they use 326 ground control points in the calibration of this data. Again, that number is identical in all 6 of the LAS files, so I don't know how many ground control points exist in the tiles that I'm using specifically. I intend to use first LP360 to create shapefiles, to do some point cloud processing, to create rasters, hillshade and slope, to generate some statistics for trails and points of interest. For example, I intend to measure canopy height at one of our student stations. ArcGIS Pro is something that I will use if necessary. I'm familiar with using their layouts to produce, final map deliverables, but LP360, the views from that look pretty good, so I may not need ArcGIS Pro, although I haven't used it at all much in this course, so it might be nice to get back to some of the original skills that we learned in other courses. Here is a sample workflow for my project. I'm going to start with LiDAR point cloud data. I'll be doing an accuracy assessment of the bare ground classification. Then I will mark out the shapefiles. As I mentioned, I intend to do the nature preserve boundary, the trails that the students hike, and points of interest. For example, our bus drop-off and pickup sites, the 6 stations that students visit while in the nature preserve, as well as labels for some of those shapefiles that students will know what they're looking at. For the trail data, at minimum, I hope to drape those trails onto the elevation models. This will be beneficial for students to see how far certain legs of the trail are. I'll also be able to generate some change in elevation for certain legs, or describe to the students on the maps the steepest sections or the longest legs. I would also like to calculate tree height at a particular workstation where students have to estimate the tree height of certain poplar and beech trees, and since we did see how we can use LiDAR to do that, I intend to do that as well. Then I would optimize the symbology to make it good enough for viewing and use on several different aspects of the trip. For example, contours might be only important at certain workstations, not while students are just trying to navigate around the park. The final deliverable will be a topomap and perhaps some 3D views. And the last workflow item I have labeled in red, which is an export to Esri Story Maps. I think the scope of my project has me maxed out in terms of my ability level, and the story maps may be an added thing for another time. But that is ultimately where I would like to go with this project. Thank you for listening to my project proposal, and I appreciate your feedback.